Hello, in this video I'm going to give a little bit of background on Enrico Fermi, another one of the big names in particle physics and quantum mechanics. And of course, like most of those forerunners, he was born at the beginning of the 20th century, and he was active in the first half of the 20th century. Here's a photo of him when he was at Los Alamos in the US as part of the Manhattan Project, which of course has got a lot of coverage recently with films like Oppenheimer and such like, but we'll get onto that a little bit later on. Fermi was born in Rome. He was an Italian scientist. He showed prodigious ability from an early age, despite being largely self-taught. He had a remarkable aptitude for picking up the subject and was very driven, both in theoretical and experimental physics. This is something that he really excelled at, that he could operate in both areas, which is one of the reasons why he was so prominent in the Manhattan Project. Now, his first major contribution to physics was in statistical mechanics. He applied the Pauli exclusion principle. Pauli was a contemporary of Fermi, and in the 1920s, Fermi applied that exclusion principle to an ideal gas. Dirac was doing exactly the same thing, and they came up with a new set of statistics to describe the behavior of these fermions, which of course are named after Fermi. If you're looking at ideal gases, I know I haven't covered that yet in these videos, but ideal gases are described by Maxwell-Boltzmann distribution. So you've got one set of statistics for describing how the particles in an ideal gas behave, and then you've got Fermi-Dirac statistics which describe how fermions behave, and then you've got the Bose-Einstein statistics which describe boson behavior. So Fermi and Dirac, even though they were working independently, they both came up with these statistics in 1926 or thereabouts. So that was, perhaps the first major contribution that Fermi had. It wasn't long until he picked up on something else that Pauli had come up with. Pauli had postulated the existence of a new particle to conserve energy in beta decay. So they were looking at these electrons being chucked out of the nuclei of atoms, but the sums weren't quite adding up. So Fermi took up this, and he developed a lot of the ideas and a lot of the early description around the weak interaction, which is what drives beta decay. So much so, it was initially called the Fermi interaction after Fermi. And he was the one, it was Fermi who came up with the name. He called this particle the neutrino. In Italian, that's the little neutral one. And that was the particle that needed to be there in order to make everything make sense in beta decay and the weak interaction. He then moved on to what led to his role in the Manhattan Project, his interest in nuclear physics and fission and such like. And he noticed that the neutron had only just been discovered in the early 1930s. It was much more recently than a lot of people would think that the neutron was discovered, and Fermi was investigating the behavior of neutrons, and he saw that slow neutrons are much better at creating unstable nuclei that will then divide as part of nuclear fission, and that was the start of the path to the first nuclear reactor. Fermi was the person who developed that. Chicago Pile 1, and then onwards to the atomic bomb. So it's that crossover between theoretical and experimental physics that Fermi really excelled at, that he could take these new ideas of particle physics and quantum mechanics, and he could turn them into practical applications. Much like a lot of these scientists at the start of the Second World War, Fermi fled Europe to the US, not because he personally was Jewish, but he had married a Jewish woman. So he fled to the US just before the start of World War II. He started work at Columbia University, and then moved on to Los Alamos from there. He died young from stomach cancer, almost certainly partly as a consequence of his work. He was very hands-on in this, highly radioactive work that he was doing. So yeah, it didn't do his health a lot of good, and he died in his early 50s. I suppose otherwise, I mean, he is known for what's called the Fermi estimate. I mean, he had a very good way of quantifying things without firm data. So, what we might describe as a back of the envelope calculation. So we'd get an order of magnitude estimate without having solid numbers to work with. And this is something which still, I think they're still commemorated even nowadays, that they have some kind of Fermi competition or something like that, where they'll ask people seemingly unanswerable questions that need quantification. Something like, I don't know, what's the mass of all of the automobiles that have been scrapped in the United States in a single month? And then you have to work through ideas of, well, what's roughly the population of the US? What's the percentage that would be driving? How often are they getting through a car? How many of those cars would be reused? How many of them would go to scrap? Things like this. So you're doing these order of magnitude estimates on the back of an envelope in order to try and come up with an answer that seems plausible. And Fermi apparently excelled at this. So yeah, a remarkable man. I mean, especially his being able to excel in theoretical and experimental physics. Okay, maybe the area that he ended up specializing in, I mean, the contribution to something like the atomic bomb is never going to be without his controversy. I suppose less so, but similarly with nuclear power. I mean, someone was going to do it at some point. But yeah, I mean, his impact on physics certainly can't be understated, as you can certainly see when people start having things named after him, with fermions and Fermi Dirac statistics.